which shows us this transaction that's going through. And then we'll see that we've indeed successfully deposited our Ethereum. Now down here, you'll see a little button, add AETH to your browser wallet. And we're going to go ahead and click this. And this will automatically add this token to our wallet. So we're going to hit add token. And we see now in assets, we have this AETH down here. We could also have manually hit added token, got the contract address, but Aave was nice enough to just go ahead and add us a little button that does it for us. AETH is what's called an interest-bearing token, and it goes up in real time. You'll see, if I sit here long enough, you'll see this number actually continually going up. This is the profit given to us from other people borrowing the ETH that we've deposited into Aave. If we go to our dashboard now, we can see we have 0.1 ETH deposited. And if we roll over it, you'll constantly see the amount go up and up and up. We can go ahead and withdraw our ETH, which will convert our AETH back into ETH with the additional interest that we got from depositing. So depositing into Aave will give us interest back as a payment for other people borrowing the ETH that we've deposited. We can also use this ETH as what's called collateral. So if I go to this borrow tab, I can actually use the ETH to borrow some other asset. Maybe I want to borrow DAI, which is a stable coin meant to always equal $1. USDC and USDT also are meant to always reflect a dollar. We can borrow what's called wrapped Bitcoin, which represents the Bitcoin price. We could borrow some Aave token, some BAT token, some Link token. We can borrow all these different tokens. Now, borrowing an asset is incredibly powerful. By borrowing, you're allowed to obtain liquidity without selling your assets. And borrowing is one of the first pieces in order to actually short sell. Borrowing in DeFi protocols is absolutely massive because it allows you to frictionlessly short sell, obtain liquidity without closing your position, gain yield on some deposited collateral. You can do a massive number of new things only in the DeFi world, such as flash loans. Now, an important note on borrowing assets on mainnet. Since we're just borrowing it on testnet and this isn't real money, this is 100% okay to experiment with and work with. However, if you borrow an asset and you do not pay attention to how much you have for an underlying collateral, you could get liquidated and lose some of your funds. So be very careful and pay a lot of attention if you're going to do this on an actual network. Now, let's say we want to borrow the Aave token, for example. We click here and we can choose the amount that we want to borrow. Now, here's the thing. Since we've placed down some collateral, right, 0.1, if the amount that we borrow ends up being too high, we'll actually get what's called liquidated. Every time we borrow an asset, we get some type of health factor. The health factor represents how close to being liquidated you are. Once your health factor reaches 1, the collateral that you've actually deposited will get liquidated, and somebody else will get paid to take some of your collateral. This is so that the Aave application is always solvent. Being solvent means it's never in debt. So when I want to borrow, I want to choose some amount that might be a little bit safe here, and so that I'm not going to get liquidated. So zoom in a little bit. I'm going to choose some number where I see a health factor, maybe like 5.6. We're going to continue. Now we'll have to choose our interest rate. When we borrow an asset, we actually have to pay some interest. This payment is actually going to go to the people who are depositing DAI or depositing the asset. The interest rate that we're going to pay is actually going to be paid to those who are depositing the asset that we're borrowing. So like how we're getting interest on our deposited collateral, others are getting interest on their deposited collateral based off of how often people are borrowing it. We can choose a stable APY, which will always be 4%, or a variable APY, which will change based off of how volatile and how in demand this asset is. For now, I'm going to choose variable, but you can pick whatever you want, especially for this demo. We're going to hit continue. I'm going to zoom out just a little bit. And this same interface is going to show up. We're going to go ahead and hit borrow. MetaMask is going to pop up and ask us if we really want to borrow. We're going to go ahead and hit confirm. And now we've successfully borrowed DAI into our application. We can even hit this little add DAI to your browser wallet to add the token to our wallet. Now, if we hit the button, we go to assets, we can now see DAI is indeed in our token assets here. Now, if we go back to our dashboard, you'll see we have a health factor score here. This is a really important score. If you click on this little eye thing, It says the health factor represents the safety of your loan derived from the proportion of collateral versus amount borrowed. Keep it above 1 to avoid liquidation. And we'll see all of our deposits here. So we still have 0.1 in ETH deposited. We also have 28 DAI deposited. You can see a whole lot of different stats here for working with our application. We can withdraw our DAI, we can withdraw our ETH, we can borrow more DAI, or we can go ahead and repay. We can either repay from our wallet balance or from our current collateral. Yes, we could repay with our collateral. Let's go ahead and do from our wallet balance. We'll hit max, continue, and we even get this little thing that says you don't have enough funds to repay the full amount. Well, why is this the case? We just borrowed this amount. It's because already since depositing, we've accrued a little bit of extra debt. Remember, we hit that variable APY, and every second it's going to tick up just a little bit. So let's go ahead and pay back what we can with our wallet. We're going to confirm. We're going to approve our DAI to be spent, and then we're going to go ahead and hit the repay button. And great. Now if we go back to our dashboard, you can see we've repaid almost everything here, but we have a little bit left. So let's just go ahead and hit repay with our current collateral. We'll hit max, continue. And this will use our ETH to pay back the collateral instead of the DAI. And then we'll hit repay. This way we'll have no more debt. Great. Now if we go back to our dashboard, we can see we have no more debt, which is fantastic. Aave is one of these applications that relies on the Chainlink price feeds in order to understand the ratio between how much you have deposited as collateral and then how much you can borrow and take out. If we look in our wallet now, we can see we still have some AETH. We also have some ETH, and now we have 0 DAI because everything's paid back, but we're still gaining interest on the ETH we have deposited. Let's go ahead, just reconnect. Let's go ahead back to testnet.aave.com. And let's just withdraw all of our ETH. Now keep in mind when working with some of this is a testnet, right? And working the way we're working right now is just on a testnet. So sometimes the testnet doesn't work quite as well as a mainnet because it's just for testing and doesn't have the exact same support. We were just working on the testnet. But if you want to go to Aave for real, you can go to app.aave.com, connect your wallet on the Ethereum mainnet, connect your wallet, move to the Ethereum mainnet, and interact with it exactly the way we just saw. Now, if we're on the mainnet here, we can see some additional pieces. When you deposit something like DAI, yes, you get 2.3% back as interest paid to you for depositing the DAI. You also get a little bit of what's called a governance token. You also get a little bit of Aave token. I know it's really small here, but this is an additional incentive that Aave has given the users for working with their protocol. Since Aave is a decentralized protocol, in order for anything to be improved or anything to be updated on the protocol, it actually has to go through a decentralized vote. So these governance tokens actually dictate and decide how the protocol improves moving forward. Now that we understand how to work with all of that through the UI, let's actually learn how to interact with Aave and interact with DeFi, all from our scripts. Learning how to do it this way will get us one step closer to being a quantitative DeFi engineer or DeFi researcher. This is someone who programmatically does algorithmic trades, algorithmic modeling, and just does everything in a programmatic sense, making them much more efficient and powerful interacting with DeFi. Now, all the code that we're going to be working with here is in this Aave Brownie Pi application, and you can always refer back to it in the link in the description or in the link in the GitHub repository and see all the code written yourself. So with that, create a new folder and open up your VS Code to that folder, and let's get into it. And Aave has some fantastic documentation that we're going to use as well. Link here is also in the description. Let's go ahead and start with our basic Brownie setup, just with Brownie init. And we got a new Brownie project. We got all our folders in here, and we are good to go. Now, if we're working with Brownie, we're actually not going to really be deploying any contracts because all the contracts that we're going to work with are already deployed on chain. All of them are just going to be working right with Aave here. Create a quick readme.md so we can know what we're doing here. Number one, we're going to try to deposit some ETH into Aave. Then we're going to borrow some asset with the ETH collateral. And then if you wanted to, I challenge you to actually sell that borrowed asset. This is what's known as short selling, but we're not going to do that here. And then we're just going to repay everything back. Great, and this will be the full functionality of working with Aave in this deployed contract. Everything that we're going to learn here will teach you how to work with other contracts as well, such as Paraswap or Uniswap, or any other type of swapping contract that will allow us to buy and sell. So let's just go ahead and create a script. We'll call it Aave borrow.py. Let's go ahead and create a function called def main, and we'll just do pass for now. The first thing that we need to figure out how to do is deposit some ETH into Aave. When we actually deposited our ETH via the UI, you can actually see when we call this deposit function, if I hit this deposit button here, oddly enough, if we go to this contract address on the Coven Etherscan, we'll see that this address is actually what's called a WETH gateway. What Aave is doing, like I was saying before, and let's go ahead and actually cancel this for now, reject. What Aave is actually doing here is swapping our Ethereum for WETH. Again, WETH is an ERC20 version of Ethereum, and this allows it to easily work with all the other ERC20s on the Aave protocol, like DAI, USD Coin, Ampleforth, Link, etc. So we actually have to do that as well. So the first thing we're going to need to do actually isn't deposit some of our ETH. The first thing we're going to need to do is going to swap our ETH for WETH. So let's even just put this in its own little script. We'll call it get weth.py. So we're going to have a function def main. I'm just going to do pass for now. But we're actually going to want to use this get weth function in our Aave borrow.py. So we're going to actually have a main, and we're going to have a def get weth. And our main function is just going to call get weth. So how do we actually convert our Ethereum to WETH, or wrapped ether? We'll even do a little doc string here. Mints WETH by depositing ETH. Now, to save gas, we could actually interact with this WETH gateway for Aave, but I'm going to teach you guys how to just get WETH in general. So we can look up the WETH contract Etherscan, the WETH Coven contract Etherscan, and we'll see here we have this wrapped ether page. And we can go to the contract and we can see that this is indeed verified. The way ETH works is there's a withdraw and deposit. We deposit ETH into this contract and it transfers us some WETH. So this is the first contract that we actually want to interact with. So we need our script to be able to call this deposit contract. So, per usual, the two things that we need to do this are going to be an ABI and an address for this WETH contract. I really like just doing everything directly from the interfaces. I've already copy pasted the interface into this here. So we're going to go to WETH interface.sol, and we're just going to copy all this right here. So in our interfaces, we create a new file. We're going to call it iweth.sol. We're going to paste it in. You can see this has all the exact same functions. It has our deposit contract, symbol, name, transfer, pretty much everything you would expect from an ERC20, plus this extra deposit piece. We'll call this iWeth. It's a common naming standard to just have I in the name of what your contract is when you're talking about an interface. So we have an interface now, and we also have an address. But again, this is our address on the Coven network. Since we know ahead of time that we're probably going to be using this on different networks like mainnet and Coven and etc., we're actually going to create a new file. We're going to add our Brownie config. Hopefully this is starting to look a little familiar to you now. We're going to go ahead and add our networks in here. In here, we're going to go ahead and add Coven. And in here, we're going to write WETH token. And we're going to add this address of the WETH token. Paste it in here. While we're in here, we're going to add the rest of our pieces. We're going to add wallets, from key, private key, and that's all we really need for now. Speaking of which, we probably are still going to want to test this locally. Now, since we've done some work with testing, we know that for testing, we can do our integration tests on Coven, because there's an integration test there. But what about our local tests? Well, this is something good that we're thinking about right now. We know that Aave